Hi, good morning, and welcome to my shop. Thanks so much for joining me here. It's the 5th of May. Oh my gosh. And I'm going to start work on this PYE radio, just the chassis here, of course. Now, this radio, unlike most radios in my shop, this one's already been in my shop. It's already gone through my shop a couple of years ago. I own this radio. And this is one of my favorite radios, for sure. And so I took care of it a couple of years ago, and I think it was performing really well. And it probably still is, but I really don't know. I have it in here to do a checkup, and I just finished another radio very similar to this, not identical, but very, very similar. And now it's this guy's turn to be brought up to a high level of performance, and then those two radios are going to face off in a big competition. But for now, it's time to check up on this guy. So I think the first thing I want to do, since I know it operates, I had it playing a little while ago, and there's nothing seriously wrong with it. I'm going to go through and do the voltage checks of the critical tube elements, the plate, screen, things like that, and see how those come out. And from there, well, we'll see how that comes out and decide what to do next after that. Okay, I think I'm pretty well ready to get going here. I've gone ahead and written the different pin numbers for each of these tubes, since they seem to keep that information secret in these schematics. So I should be able to go each tube, do the pins, plate, screen, and in some cases two plates. Okay. I'll do the first one here on video. So V1 6SK7, that's that tube right there. And plate is on 8, and it should be 75 volts. I gotta turn the set on first, Jim. You got a little ahead of yourself here. Okay, we're gonna this one. Okay. So I think this is off. Here we go. No action on the dim bulbs. That presents a problem. Okay, problem solved. Try again. Oh, my power supply's got this. I bumped the switch off on it. Okay, one more try. That looks a little better. Okay, switch is off. There we go. This is the hardest part of the whole thing. Bingo. All looks normal. So the band we're on, we're supposed to be on the broadcast band. And let me touch the antenna here. Huh. There we are. Okay, radio's operating. I'm just going to ignore that noise for now. RF amplifier 6SK7, pin 8 is the plate, 75 volts is the expected voltage. The meter over here is on the 150 volt scale. So the 75 volt reading should be straight up. Pretty well straight up. Okay. Let's just check, before we do that, let's just check the B plus here. B plus, the highest one I get in here is 245 volts on the output tube. Let's see what we can find. Hello, radio. Okay. There's the capacitors. I think I can get right on one of them right here. So that's reading on the 500 volt scale, that's reading 300 volts. So, okay, that's good. Now, should only be 75 on the plate of V1. Plate is 6. Trying to spot the gap. The key. I'm going to stick my head right in front of the camera here. Okay, there. So there's the key. There, and pin 6, wasn't it? Pin 8. So I think this is pin 8. Okay, so looking over at the meter, I'm still up on the, back to the 150 volt scale. Wow, so that's 100 and pretty much 150 volts. And it's supposed to be 75. More is not necessarily better. Oddly enough, the plate should be 75, the screen should be 80. Isn't that odd? Usually the screen is less. Screen is 6, 2 back from 8. Screen. Way high, well, not way high, 95. 150 and 95. Okay, so I'm going to go through all the tubes, write all this down, and we'll analyze what the result is. Okay, I've completed that, and everybody's got voltage where they should have voltage, but there's something consistently wrong about all these numbers. They're all way too high. Like for instance, the plate should be 215, it's 250. You know, the screen should be 80, they're all 95. The plate here should be 90, it's 120. Everything is elevated everywhere. On the output tube, the plate is supposed to be 245, it's 300. And the screen is supposed to be 215, it's 250. Everything is high. Everything is high, roughly the same proportion, roughly. So what I'm curious about is what's going on in the transformer. What kind of output is coming from the transformer? And it is actually one of the measurements here. The last measurement is anode to anode on the rectifier tube, which I believe is just the output of the transformer. 540 volts AC. To do that test, I'm going to use this meter because it's ungrounded, isolated from everything. I wouldn't want to use my my vintage meters, plugged in the wall meters for this kind of thing. Plate to plate. Plate to plate. I don't know which ones are the plates. Which ones are the plates? Did I not write that down, or did I? I did write it down. 6 and 4. Okay, so I want to look at the voltage between pin 6 and pin 4 on the rectifier tube. That's the rectifier tube there. Pin 6 and 4. Pin 6 there, pin 4, 1, 2, 3, 4, 1, 2, 3, 8, 6, and 4. Oh, how come? Make static. Didn't like that. 600 volts. Just about precisely 600 volts. It was supposed to be what, 540? 540. Why would it be high? Do I not have the right rectifier tube in here? Really quite sure I do. Let's cut the power off at this point. Swing it around. And we'll take a look. There's the tube. Ooh. So when I brought this radio out a couple of days ago, the rectifier tube was missing, and I must have stole it for another radio at some point and forgotten about it. So that's a recently installed rectifier tube. What's with it? I'm sure it's a 5Y3, and I'm also sure it'll burn the heck out of my hand if I touch it. So let's see if we can get it out here. She's a hot one. Whoa, whoa, whoa. Okay. There's no label on this. This was in with the 5Y3s I have. That means I may have spotted enough of a label in here. I mean, it looks like a 5Y3. I can't imagine it's something else. That's somebody else's green check mark. That's not my green check mark. 5Y3. I don't think I bothered checking it. I had a check mark on it. Why would I check it? And if it's wearing out, it's not going to result in a higher B+. Could it be a different tube? I just don't think so. I don't get it. We try another one. And we should test it. We should test this tube and try another one and see if we can calm it down. If we can't calm it down, and the output from the transformer seems high, then maybe that's just the way it is. It can be a little extra voltage, a little extra good, wouldn't it be? Okay, here's a bunch of 5Y3s. And this is the one from the radio. You can tell it's quite warm still. So if we look at these and look at the plates inside, how they're structured, do they all look exactly the same? Not at all. Wow, those look dramatically different. This is what I'm used to seeing. Let's just see if I can spot the 5Y3 on there. So sometimes tubes have such a specific look that you can actually just look inside and figure out what it is. That says 5Y3 on it. Oh, that says 5Y4 on it. Doesn't it look similar? What's a 5Y3 and a 5Y? That's a 5Y3, but I don't think you can just pop a 5Y4 in for a 5Y3. I think that would be a pretty disastrous deal. So this one without the label. What does it really look like? You know what it looks like? It doesn't actually match any of these. It looks different than all of them. Huh. Maybe it's not a 5Y3. You really can't substitute. Let's check. I have enough substitution books. I have substitution books I can substitute for other substitution books. Let's pick one. I think a lot of these are actually the same book, just being published by different people. So if we go 5Y3 here, see what it says. 5Y3. Oh, look at all that. Oh my gosh. These are AR5, AR4, so wow, there's all kinds of them. But some of these are little, like 5Z4, never come across one of those. Okay, long list here. 5Y4 doesn't make it in here. What about 5Y4? So 5Y4 can be replaced with just other 5Y4s. Let's go another step with this. So we go 5Y, I mean they're right next to each other in the book here, aren't they? 5Y3, 5Y4. So 5Y4, 3 and 5 on the plates, 5Y3, 4 and 6 on the plate. So you cannot make that mistake. You cannot put that in and think something good's gonna happen. Heaters are different too. Oh, that's weird. 2 and 8, 8 and 7. I don't think it's weird, but so okay. So pretty certain that this has to be a 5Y3. Or it wouldn't have done anything in there. We will test it as a 5Y3. I'm going to set up my tester here, and we'll go ahead with that. Okay, we're all set to go here. The first one we'll put through is the still warm supposed 5Y3 in here. Let me just do a quick double check. 5 volts for the heater. No settings. 07030. 07030. P060. P060. Very good. 25. E. Oh, good job, Jim. Wow. Okay, there we go. So in this tester, when I run the test, all it has to do is get up above this line here, which you may not be able to see in the video. It's very hard to see, but there's a little note above this line, and rectifier is okay. Okay, look for shorts. That should show, and it did, just the way it did. That's normal for this kind of tube. Rectifiers and diodes. So it's testing perfectly fine as a 5Y3. Why would I bother? Why would I bother with any other one? Well, let's try one. Let's try that weird looking one. They're all kind of weird looking, aren't they? It definitely says 5Y3 on it. Large plates. Better dissipation. Maybe. You know what? I only checked one plate on that last tube. I'm going to have to put it in again. 2 plates to check. Okay, let's go for test. Pretty much the same place. Other plate. Pretty much the same. I'm going to bring back the warm one. Hard to see how any kind of problem with a rectifier would result in higher output voltage, except putting in the wrong rectifier. And even that, it would be a tough one to explain. Okay. There it is, looking good. E2, same thing. If it only half this worked, that radio wouldn't have worked. There's nothing going on here. I'm not going to find any solution to the high voltage thing. Does it need a solution? That's a good question. That's a really good question. So one plate, one of these tubes is running with a plate at almost double its design voltage. The design voltage is 60 and it's running at 110. Let's look into that a little bit. As I find my note here. That one was supposed to be 90. It's running at 120, so it's not quite double. The frequency changer 6K8. And the radio is revealing its vintage with these tubes. Three-letter tubes or 3-digit tubes. 6K. FTHI. Really need to work on the alphabet here. 6K8 triode hexode converter. And what am I hoping to find out here? The recommended operating voltage. And this would be on the oscillator part of this tube. This tube is two tubes in one. A little hard to see in the camera there. Oscillator side. How do they show it here? Oh, let's talk about hexode and triode. That's how they do it. Triode plate voltage 125 max. Oh, that's not quite what I wanted to find out, but wow, it's pretty close. 110. So we're pretty close to the max. In typical operation, triode plate voltage 100. So they're trying to run it just under that. They're all high. What do you do to knock down the entire B plus voltage in this radio? Could stick some kind of resistor in and do stuff, but you know what? I'm not a radio designer, and you know, these things can have consequences, unexpected consequences. How bad is it having this thing run high? Now I'm feeding it. I think I was feeding 117 volts, but often the input voltage here at my house is actually higher. Today it's on this meter, it's 120 volts. I don't think it's 120 volts. Can't we find out on this? No, because this is a variable thing. Yeah, no. 120 volts. So that would raise it from the 117, 120, you know, that's only what, another 2% or something. That's hardly going to make a difference. Never been concerned about it before. It's higher, not lower. Output tube. Let's check the output tube. It's running at 300 volts. Let's see what this guy says about doing that to an output tube. 6V6. QRSTUV. See? Getting better. 6V6. Next page. There it is. Beam power tube. The 6V6 is equivalent in performance to a 6AQ5. Interesting. Maximum ratings. Maximum plate voltage 315. So I mean, we're right there. 300 on it. Grid screen voltage maximum 285, but we're nowhere near that. We're nowhere near that. It's way down from there. Well, we're pushing everything towards the limit. I should move to a house that has a different transformer feeding it. I have a little bit of a lower voltage in the house, and then the radio will be okay. I'll go tell my wife that that's the plan. We gotta move. Honey, we gotta move. We got 2 extra volts on our outlets. We gotta get out of here. Oh boy. Well, I'm going to stop for now and just let that bubble around in my head a little bit about what to do. I don't think I'm going to do anything. I think I'm going to just carry on and leave everything just as it is. Okay, hold the horses here. I didn't even get out of my shop before I realized why those voltages are high. And I know why they're high. Here's a note here. It explains it. Measurements taken with a 500 ohm per volt voltmeter. So 500 ohms per volt, that's a lousy ohm meter. That's not a very, or a lousy voltmeter. That's not a very good one. Now I'm using something that is way higher in impedance. It's really not loading, like I'm using this meter over here. It's really not loading the circuit down at all. But they're warning here. They said, why in heaven's name did they do this test with a crappy meter? Because they anticipate all the servicemen have the crappy meters also. And they're going to end up, and so if they don't make the voltage test with the crappy meter, everybody's going to think there's a problem in their radio when they use their crappy meter. Now I didn't use a crappy meter, and the result is I'm reading all the voltages higher. My guess, everything's fine. I feel good about just leaving it all. Hey, the radio works. Next thing is to verify the alignment, and oh boy. Okay, so I did some tests on this radio in a previous video, and so here's the result from that. And what this is me tuning different spots on each band, and then checking to see what frequency the radio is actually tuned to, or something of that sort. And I resolved into this diagram here, which indicates which bands are well aligned and not so well aligned. So that's well aligned, that's good, that's good. This one in the middle and at the high end of the band is low. This one's a little off at the lower end of the band, excuse me. These ones are all a little bit off. So not too bad though. I think the thing about this radio is it has a band spread dial that's spread enough that you can dial in very exact frequencies. And so it's well worth trying to get this radio aligned as close as possible. I just finished doing a radio, actually I believe an updated version of this radio. A little bit different in some ways, but in other ways very, very similar. So this radio, like the other one, when it's out of the cabinet, the glass stays back. This one comes with this dial, this index dial here. And the index dial is referred to in the alignment instructions. So that's great. And on the other radio, and you might, if you watch the videos, you saw I wrote actual numbers on here, frequency values based on the pointer at the front. So funny, older radio seems to have better facilities in it than the newer radio. And what's even more interesting, if it is more interesting, so I think this thing I just showed you up here could be called a tuning scale. And here it says, fitting a new tuning scale. Fitting a new tuning scale. Well, there's nothing fit about that one. That's right on the metal plate. Huh. Place scale plate in cabinet aperture and screw the clips lightly in position. So what are they talking about here? So I'm guessing now, here, trimming scale, and they show it there. I'm guessing now that for a while they produced these radios with no trimming scale. They then offered a scale you could buy or get, and then you can fix it in the radio. But of course the challenge is, where do you put the scale? Exactly how do you adjust it? And this is the instructions for adjusting the scale when you mount it on the radio. So, funny history to these things. Obviously they did away with all that and they made it permanent, but then when they released the next version of this radio, the updated version, they forgot about all this again. How could they do that? Has to be a change of people, a change of engineers, I would think. Just skimming through there really quickly. Yeah. Okay, what we want to do now is set the radio up for alignment and then see if I can't revise the alignment and make it better. So just so you can see, over here they're giving a frequency, and this is the alignment chart. They give a frequency. It's hard for me to read. 7.3, but then they give a number on that scale. 44.5. Boy, it would be pretty interesting to whip this back into the. You know what I'm going to do? I'm going to whip this back in the chassis, into the cabinet. I'm going to dial up a certain number, one of these numbers, and then we're going to look and see if it matches what's on the scale. We'll see. We will see. Well, that sounds interesting. Okay, let me do that. Yeah, I'm figuring it's a simple matter to slide this back in the cabinet, except when I look, this is laying loose in here. Well, it's forcing me to look at this a little closer. Now, this radio, just like the last similar one I was working on, has a quick release system for the chassis. So these two bars sit here, bolted in, they stay put. And all you got to do is just release the screw on the cabinet, on the chassis here and over here, and I guess maybe there's three, No, I don't have 3. And chassis slides out easy, supposedly. Found out it wasn't so easy on the last one. Look what they've had to do here to give space for the hole that the controls are going through. They've had to drill out the speaker board, and that tells you something about what's going on with putting the chassis in and out here. So how did this come out? Can it just pull through? It's got a washer. Well, I guess maybe if the washer got a bit tippy or something. Doesn't look like it though. Okay, so I'm going to fit this back in properly and fit in the what a handy thing. This has been the handiest thing, these rails. Wonderful. Huh. Okay, let's try putting this radio back in the cabinet. I have a little bit of a problem right in here, I think. Let's see how this goes. No room for the hands. Just tangle it up a little bit. Over. I think I made it there. So there are some pins that are sliding into holes in the front of the cabinet. There's a pin sliding into it, supposedly. If you got the dimensions right. Now, how are you supposed to know if that's working out or not? It's all hidden way up in there. Okay, well, I can actually feel it. So here's the hole, there's the thing. Oh, they're really close. Feels like it has to be lifted up to go into it. What was that? Oh. Okay. Let's see. Yeah, those rails. Really thumbs up on the quick release rails. One's in. There it goes. Got it. There we are. It's really critical to get this right because it will cause the front of the radio to be up or down. I'm going to be matching the pointer and the dial. I can't have the radio out of sorts. Even having the back jacked up a little bit kind of tips the radio forward. I'm not going to worry about that a little bit though. Okay, so the objective now is to set the, well, let's do one. Pick one here. So 9.6 megahertz should be 44.5. Look, there's a whole bunch of them that are 44.5, and as you go through the bands, they're identifying different frequencies. They must all line up the same. Let's put this on 44.5. And we'll turn it around and see what frequencies it shows. Okay, so now the way this works, I can reach the tuner. The scale. Let me tip up the radio just a bit here. Okay, the scale. I want to get to 44, so oh, I'm almost there now. So that's 34 40 has a hole knocked through it. 50 and 60. 44. That's practically right on the money here. So I think the bracket has a center hole that you're lining up. Okay, now I gotta get my get things set here. I gotta get my head down. No parallax allowed. There's a lot of potential parallax here. Okay, so that would be 44. I mean, really. 30, 20, 30, 40, 44. I think it said 44.5. Yes, just no way you could be that precise with it. Okay, so that's got to be about as good a 44 as I can get. What do we see on the front? Okay, 44 should relate to looks like 6.1. So there's the pointer. There's 6.1. Should also relate to 7.3. What? 7.2. Oh, look at this. All these numbers are exactly the same all the way across in terms of position on the scale. They made it so 44. So you set it to 44. You do everything from one setting. I didn't realize that before. I think what? I think when I did this before, I may have. No, I couldn't have. I was going to say maybe I ignored this, but you can't ignore it. You have to use this. So that's interesting. That raises a quandary. The quandary is, what do you do? Do you use the 44 in the back in this position? No way. If you did that, then 6.1 is going to be here. I'm going to tune this to where it should be. And never notice that. Straight across. Right there. And that's roughly middle of the band, of course. That's what we're trying to do. So that should be on 44.5 on the back. Okay. Let's go back there again. Maybe I read it wrong back there. Let me get the close-up camera and we will look closely at this situation. Oh, it's way off. 30, 40. Way off. So yeah, so I got it off here. 44.5. Well, I think that would be 44.5. See how much parallax there is, because that's way off the scale. Like way off the surface of the scale. Okay, I didn't get it done right the first time. Let's see what we got this time. Well, it looks better, but it's still high. Well, that's interesting. Probably what I should do is I should discover my own number for... Now wait a minute, am I using the right part of that bracket? Maybe things were lined up at the top of the bracket. The PYE quick release permits removal of the chassis without turning the cabinet over. Special flywheel tuning needs no maintenance. Why would they even say that? 100 division trimming scale is printed on the back of the scale reflector plate for use when trimming the receiver outside the cabinet. The top of the pointer carriage serves as an index for the scale. The top of the pointer carriage. So again, they're talking about a scale as if, oh. So sorry about that. So sorry about that. So they're talking about the scale as if it's something that's been added in by somebody. No accurate frequency. Is there any hint here? Well, there's some other places I can compare. Like top of pointer carriage. Top of pointer carriage, that's what I'm looking for. Okay, so they're using different guidance. I use the center hole, they're using top of pointer carriage. Okay, let's do that. Top of pointer carriage. Let's use the other camera. I'll try not to forget we're using it. Top of pointer carriage. So that would be the top. That would be like 45, 44 and a half. Huge amount of parallax. Okay, well I bet you that's really close now. I guess what I'm doing here is I'm finding out all the potential mistakes that could be made, and I'm making them now before there's any consequence from them. Well, look at that. Well, now it's a little bit below. Here, let me do this and do this and do this. There we go. Now I'm going to try to hold the camera for 0 parallax. Look, it's gone below now. So still kind of have the same issue here. I really think it makes sense to put that pointer on the 6.1, 7.2 line. Make a note of what the index says. That's where I keep my magnets, by the way. Make a note of what the index number is. And maybe do that, you know what? Maybe do that. Do that with each one of these. Because these other numbers here sort of correct the index. Pointer. So these first two, you're just closing the capacitor because you're doing the IF cans here. So really, it's just 94, 6.5, and that's it. Just three spots. Okay, that's great. Okay, I'm just noting how all the knobs are off center from the cabinet, but those rails force the chassis to go in a certain position. So, close. What we want to do is 94.5. No, the other way around. 550 kilocycles. 550, way up here. Make sure I've got no parallax happening. Do you notice this radio is tilted back slightly? The face of it? It's not straight, and that's really nice. Sit at a desk and look at this radio. It's just aimed right at your schnoz. It's great. Oh yeah. Okay, 55. And we'll spin it around. Find out what number that actually is. 55. And we're going to use the top, like they said, because we're going to want to compare. More light. I got to make sure, see, I mean, the parallax here, they're talking half a division. That's pretty tough to do with the kind of parallax that's in here. So first I'm looking with my eyes at the position of the camera to try to ensure there's no parallax. It hardly looks straight on. This would look more straight on when you look in the camera. Well, maybe it is. Top of the bracket must be the bracket part that comes around the front here. Oh my gosh, look at that. Look at that. Just let me try it with my eyes here. It's a little easier to position my head correctly than the camera. Okay, looking straight on. That would be 94 at the top of the bracket. 94. Okay, and what's it claim? 94.5. How do you explain that? It's correct at 94. Okay, we'll try the other one. 1500. Supposed to be 6.5. 1500. 1500 on a non-linear scale down here. I'll make that out to be 1500. It's supposed to be supposedly 6.5. And we'll take a look. And it's not 6.5. That's I'd say that's 9.5. Just making a note. Now we'll check the 44. The middle one here. .1. Okay. And the number is 40, 30, 45, 46, 46.5. No, not 46. No. What did I do? Yeah, that's right. Yeah, 46.5. Right. 46.5. Right. 40. Just right here. 46. Okay. IF alignment. So I'm going to bring the radio out now and set it up to check the IF, and that's probably as far as I'm going to get today. Let's just look at this capacitor for a minute. The other radio, the newer version of this radio, had 3 sections, but actually had 6 sections. This one has 2 sections, but 4 sets of plates. I learned from the other radio, it was a bit of a struggle to discover what was really kind of obvious is. Yes, sir. Yeah, hang on a minute, okay? These are for the non-spread band tuning. That's really only the AM band in this radio. All the rest, I believe, are using these 2. One is oscillator, I'm going to guess this one, and the other one is the tuning of the antenna or the tuning of the intermediate stage. The other radio had 3. This one only has 2. What happened to the third? Why is it not needed here? If we look at the coils in this radio, they're essentially identical to the ones in the other radio. Same number, well, okay, there's a few less bands, but same structure, same arrangement, 3 clumps of coils. You think a clump per section. Clump. Where's the third section? So that's a curiosity. What I'm thinking is what they've done is they've forsaken the antenna tuning. Oh, aren't you excited? They've forsaken the antenna tuning for the sake of fixed tuning of the antenna. I think that's what they've done. I'm not really sure. Yeah, okay. Okay, I have to go sit with my cat for a while. He needs some lap time. Okay, the very first step of doing a 455 alignment on the IF transformers. Low frequency end of broadcast band, gang fully meshed, and pointer lined up with spots at end of tracks. Lined up with spots at end of tracks. What tracks are they talking about here? What spots? When you have it in the right position, tuned in the right position, you should be seeing 100 on the scale. Top of pointer carriage, 100. So I don't know what they're talking about here, lined up with spots at the end of the tracks. Can't find any spots. I don't know what they mean by tracks. I don't know. But the 100 thing. So the tuning capacitor, well, you can see it. Now it's closed completely. And if you look carefully, it's right on 100. The top of that bracket is lined up right with 100. That's good enough for me. I think you know, one of the very first things you want to do when you do an alignment is make sure the pointer is on the string in the right place. That's what we're doing here. So it's fine. That's good. Good show. First hurdle jumped. And now we're going to do the two transformers. So I have to set up some equipment for that. I'm thinking maybe we should sweep them with the sweep generator and see that and we'll get the shape of the response curve and everything that way. Yeah, let me set up for that. Well, let's take a look at the schematic here. One of the differences between this radio and the other similar radio is the other similar radio had 3 sections in its tuning capacitor, and this one only has 2 sections. How come? Well, also on these schematics, same as the schematic for the other Pi radio, they don't really make the tuning capacitor leap out on here. Usually they're bolding it or they're doing something so the main tuning capacitor leaps out. It doesn't. Here it is. C10 and C11, and over here is the other, C20 and C21. Now you can see those are connected into switches. Into the switch here too. So these are the large plates. They're not trimmers. They're the actual tuning plates. For some bands, all these bands, you're using this one, C10. And for one band, you're using C11. So C11, we'll take a look at another diagram here. So just remember that. 10 for a bunch of bands, 11 for one band. Okay. 10, can you see it's the small plates? For a bunch of bands, C11 for one band. So the thing about these bunch of bands is on this radio they're all spread bands. They don't need a large variation in the tuning capacitor to tune across the band. So they actually physically have a smaller tuning capacitor with less plates there. So these 2 small guys are doing all the shortwave bands, and these big ones with multiple plates, many multiple plates, are just doing the broadcast band. And this is not evident when you first look at one of these radios. None, at least to me, none of this was evident. So that kind of so what's going on? That it has 3 sets of coils, right? It's got a set, and a set. It's got a. I may not have this right, but it doesn't matter. One set is oscillator, one set is antenna, and one set is the intermediate tuned circuits. 3 sets, but only 2 capacitor sections. The other radio looked basically the same. 3 sections. What happened? When you study the schematic for this radio, it becomes apparent that there's no attempt to tune as you turn the dial. There's no attempt to tune the front end of the radio. You tune it once, probably for a peak in the middle of the band, and that's it. And you think about it, that makes some sense, because again, this is not, a big spread band with, a couple megahertz across it. I'm sorry, a non-spread band. It's a spread band, so it doesn't have a lot of tuning involved. So it could be these ones, if you just fix tune them kind of for the center of the band, and that's good enough. They're not sharp enough to cause a roll off towards the end of the band, but that would only be true on the spread bands. The broadcast band couldn't do that. Now, the broadcast band also, when we do the alignment on it, it's at both ends of the broadcast band. You do the alignment, whereas all the shortwave bands, you just do it in the middle. So good. So good. Okay. Have I got everything set up? I think I got everything pretty well set up here. Plug in the radio. I have the sweep running at the IF frequency, and I haven't turned this on yet, have I? No. And I have sweep output here, and it's going to go up here, chunk, and fed into the grid of this tube, and away we go. And we're just about ready to start here. I don't see why. I should have the radio operating already. Have you noticed I'm flying the Canadian flag these days? Okay, let's give it a little bit of volume here. Hello, hello. Well, maybe I haven't hooked up anything here yet. Could it be I don't have a speaker connected? Yeah, that could be why we're not hearing anything. Lots of speaker terminals here. But we're going to go on the back. Okay, bit of a pop. Not really. When the volume's turned down, the set goes into oscillation. Could be there's some wires I disconnected here previously. It could be that's the cause of that. There we are. Let's just good show. Okay. I have my oscilloscope connected to the input of the volume control, and I also have the ABC meter connected when I do this to the same thing. Ooh, that introduced a hum. Let's take it off. I don't like that. We'll go without it for now. We don't need it. I should just be able to turn up the signal strength here, and we should see a response on the scope. Thing. There we are. Okay, up on the sweep signal. Nada. Do I have the volume turned right down? No. Oh, I didn't connect the signal generator yet. Okay. Down, down, down. Down, down, down on the volume. Okay. Signal generator. Sweep generator. Hot diggity dog. That came through. I think that's better. I think get rid of the strange motorboating. I wonder if that motorboating is working right through the ABC. Could well be. Okay, well, I should be able to turn this up now. You can't quite see it, but there's actually radio static on here. There we are. Radio static with no antenna connected. Now, what we want to find out is that at 455 kilohertz? That's what this whole thing's about. What I'm doing here. Shape is nice. Let's just see what frequency that's on. So I'm going to connect the other signal generator here. Okay, the signal generator is actually set to 447. Wow, I'm having deja vu here from the last radio. Let's adjust it here. Oh, there we go. So Zippy, where's the max? Right about there. And when we check the frequency. Now my counter is a little low. It counts low, so 454 is really 455. I mean, there's virtually no difference there. I'm making little tiny movements. So she's on the money. Very good. I don't need to do anything with the IF. We should investigate this at this point. I would like to be able to turn the radio down without that. What happened? How come everything went so quiet? What happened here? What took place just now? I gotta stop and watch back the video. What happened? Well, I did watch the video, and it just seems to stop working on its own here. There's a buzz coming out of the speaker. It appears to be no signal reaching the radio from the signal generator back here. How can that be? Here we are. That's not quite right. Let's get this out of here. I have no idea what happened, but everything seems different suddenly. What could that be? Let's disconnect this. A nice neat line here before. Now I got a schmozzle. That's interesting to see. So the sweep is still sweeping right through 455. I don't, did a tube fail right in the middle of this? Oh, I know what needed. Maybe it's time for this. Okay, yeah, time for some rubber mallet treatment here. This hurts me more than it hurts you. Pretty gentle with the rubber mallet. What has happened? Holy smokes. What was I doing? I wasn't really doing anything. I was fiddling with the volume control, my hands away from it, and then boom, something happened. We saw what we needed to see. The radio's aligned properly in the IF. We should pass on this and move on to other alignment actions on the assumption that whatever happened here is a bunch of nonsense and not consequential. Non-consequential thing happened. I don't know what happened. Okay, well, from here on, oh God, you know, I think I need to just play the radio and just make sure it's still working to some degree, to a good degree. Let's do that. I'm going to take off volume down, take that off there, put this guy on the antenna. Not there, but we will go up into the broadcast band. We're up around maybe 800, something like that. It's not a terribly strong signal. I'm on the wrong antenna. It probably would work, but I really should be on this. Volume up. That's full. And let's tune it a little higher. Make sure it's within the range of my signal generator. Get a bit of a belt. Oh, another. Oh. Okay, I see what I'm doing here. Going up from 9. So let me tune the radio. I didn't hear it. Okay, so now we're well above 9. Let's find it. No, it's a no-show. What's going on? I'm pounding it with a big ugly signal. There it is. The whole front end of this radio just disappeared. Well, once again, Jim, you fixed the radio really good. What could be snuffing the signal by accident? I still have a capacitor hanging off the grid up there. I don't think that would cause it, but let's get rid of it. Doesn't make any difference. Something happened. Something suddenly happened. Well, I think that's where I'm going to start tomorrow. Start with something suddenly happened, and we'll carry on from there. Because look, it's sandwich time. So thanks a lot for watching, and I aim to get this radio working beautifully.